Okay, good morning everyone. So let us start with the next part. I guess we had finished up till exercise 2.4. Okay, so now we are going to start, after that we are going to start the elementary transformations. Now when we talk about transformations, suppose we have a matrix, let's say A is our matrix, and the elements of A are given to us as 1, 2, minus 1, 3, 4, 8, 1, 6, 2. Okay. Now when we talk about transformations, okay, this is not visible. I can see online students are not able to see. Just give me a minute. Just a minute. Yes, I hope it is visible now. Just give me a minute. If this is our, let's say this is the matrix A, and now suppose if we have to perform different transformations on it. The meaning of elementary transformations is that you can either do row transformations or column transformations, but whatever you do at the starting of the sum, the same transformations you have to do. Means, what is the meaning of that? If I decide that I have to do row transformations, then from the starting I am going to do the row transformations. Okay, now let us see how we are going to do. The row transformations, you know the horizontal are the rows and the verticals are the columns. So we are going to do it horizontally. Now, suppose this is the matrix given to us, and if I have to convert this to an upper triangular matrix. What is the meaning of upper triangular matrix? These particular elements I have to make them as 0, or I have to convert them as 0. So this is called as an upper triangular, okay, whenever these elements will be 0. So now what transformations I am going to do? See, I need a 0 over here and over here. So first step, what I will do, R3 such that it is R3 minus R1. So I am going to transform row 3 in such a way that I get 0 at that place. So first row will remain as it is, second row will also remain as it is, and the last row is going to transform. So 1 minus 1 is 0, 6 minus 2 is 4, and 2 minus of minus 1 becomes 3. Okay. Now after this step, what do I need to do? I need to change these elements, this element to 0. So what step I will do? R2 such that, so here I cannot mix row and column transformations, that is not allowed. So as you can see over here, R2 I am going to change in such a way that R2 becomes R2 minus 3R1. So basically now R2 is going to get transformed, as you can see over here. Okay, so as you can see, R2 is transformed in such a way that it becomes R2 minus 3R1. Now again the matrix A, R1 will remain as it is, R3 will also remain as it is, only R2 is going to change. Okay. So how will R2 change? Let us find out. I am going to write down R3 also. And now I want to change R2. So R2 I will change as R2 minus 3R1. Okay. So now 3 minus of 3 into 1. So answer is going to be 0 over here. Next step, 4 minus 6 is minus 2. Next 8 minus 3 into minus 1 becomes plus 3. So 8 plus 3, 11. Okay. Now there is only a single element that is left. So in order to convert this particular matrix into an upper triangular matrix. Okay. So that means we have to convert this now. Okay. We have to convert this to 0. Okay. So what can be done? What I am going to do now? First step, what I can do is I can divide R3 by 4. Okay, if I divide R3 by 4, or what I can do is, there is one more method. I can change R3 such that it is R3 plus 2R2. Okay, look at this transformation carefully. Why I have done this? Because I want this element to turn to 0 so that it becomes an upper triangular matrix. So as you can see over here, what I am going to do is, first 1, 2, minus 1, 0, minus 2, 11 will remain as it is. Now R3 is going to change as you can see, so this is going to be 0. Next step, 4 minus 2 into 2, that becomes 4 minus 4, so here I am going to get a 0. And now 3 plus 2R2, so 3 plus 22, so that is going to give me the answer as 25. Now is this converted into an upper triangular matrix? Yes. So now we say this particular is converted to upper triangular matrix. Have you understood? So now from the starting, as you have seen, I have just done the row transformations. I have not done column transformation. You're not supposed to mix row and column transformations. Have you understood this part? Now let us go to the next point. The next point, as you can see here, is that so basically what we have done over here, from the beginning we have done only row transformations. Column transformations we have not done. So I hope you have understood this part. Okay, if you want, please write along with me so that you understand it very well. Now let us go to the textbook part, where they have given you interchange of any two rows or columns can be done, multiplication by a non-zero scalar. So I have talked about this. When we are going to multiply anything with a non-zero scalar, what is the meaning of this? See, in this particular example, as you can see, R2 plus 2R1. So that means 2 is a scalar which is multiplied to each and every element in row 1. Okay. So when any elementary row transformation are applied on both sides of AB is equal to C, the prefactor A changes and B remains unchanged. So the same row transformations will be applied on C as well. So as you can see, A is given to us, B is given to us, and AB is nothing but C that is given to us. So now if you can see, this particular matrix is going to get transformed. So first step, what they are going to do? They are going to multiply matrix A, matrix B. Okay. So whatever answer they will get, as you can see over here, answer is nothing but C. So hence it is proved that even though you perform transformations, the end result is going to be one and the same. Have you understood this part? Please write in the chat box or write on WhatsApp so that I understand you've understood. So now let us go to the solved examples. The first one. Here, as you can see, they have given you apply row transformation. So basically when there is a double arrow, that means you are going to interchange R1, R2. Okay. So instead of R1, you are going to write R2. Instead of R2, you are going to write R1. So as you can see here, R1, 2, they have just interchanged the two rows. Okay. So when there is double arrow, always remember it is interchange of those rows. Now the next, you have to apply transformation C2 minus 2C1. So as you can see here, the same thing is done by them. These sums are very easy, they are not difficult at all. But you have to just remember that you are not supposed to mix anything up. Okay. Now if you can write this down. Okay, you are not able to see this, then wait, I am going to change this a bit so that you will be able to see. Okay, I hope it is visible and clear to you now. So now, this is a very important thing, inverse of a matrix. Please write it down. If A is a square matrix of order M, and if there exists another square matrix B of the same order such that AB is equal to BA, both are equal to I or 1, means I is nothing but an identity matrix or a unit matrix of order M, then B is called as the inverse of A and it is denoted by A raised to minus 1. So we will read this as A inverse. Okay. So using this notation, if you can see, A multiplied by A inverse will always give you the identity matrix I. So A into A inverse is equal to I. Now let us go to the uniqueness of an inverse of a matrix. What is the meaning of that? Even though there is a matrix that is given to you, and if you try to find out the inverse of that matrix, it is going to be unique. The inverse of the matrix is going to be unique. You cannot compare. As we say, you know, in this case, see, up till now, in algebra of matrices, what all we have studied? We have studied addition, subtraction, multiplication. I have already told you there is no division. Okay, so instead of division, there is a concept called as inverse of a matrix. So Nidhi, have you understood this concept of inverse of a matrix very well? Okay, let us move to the next part. If you have not understood, please feel free to talk to me. Okay, chat box is disabled, is it? Wait. No. Okay, so you are able to understand. 2.4 exercises left, I know, but see, in 2.4, what all have we done? We have not finished, entire exercise will not be done by me. I am going to do just a few sums which are important. So have we done those sums, Nidhi, from 2.4? Please let me know in the chat box. If we have not done those, then I will just mark the important sums and we will solve them. Because what I remember is we had done the algebra of matrices. I had also explained you the concept of transpose of a matrix. Scalar multiplication was also told by me. Just a minute. So 2.2 was done, 2.3 was done completely. Let me check, wait. So 2.3 was done, okay. Now let us move to 2.4, okay. Now this is a 2.4. From this 8 transpose, question number 1 is very easy. You can do it on your own, okay. Now we can go to exercise. From this exercise, question number 5 we can do right now, okay. 5 is important. Then 8 is important. So 5, 8, 10 may say we will do the first one, and 11 will do the second one, okay. So first let us do so question number 1 is for you, you have to do it yourself, okay. I am not going to do that because it is very easy. We are directly going to do question number 5. I have already explained you what are elementary row and transformations right now. Those elementary rows transformations are very important when we are going to study about inverse of a matrix, alright. Yes, wait, let me see. I will repeat inverse of a matrix, don't worry, but first let us finish this exercise, okay, because I have not even completed that concept. Before that only you have told me that exercise 2.4 is remaining. So we will first do exercise 2.4. From that we are going to do question number 5. Just a minute, I'll just write down the sum. A and B are given to us. So first what is to be done? First find out what is A plus B. Find out what is addition of A plus B, because I will try to complete this exercise first and then only we will move to the next part, that is inverse of a matrix. So we are going to do question number 5, the first one. As you can see clearly over here, wait, I am going to show you what is to be done. Okay. So now from 2.4, exercise 2.4, sum number 5. Wait, I'm going to change the screen for you so that it is visible to you. Okay, this is example number 5. Okay. Now, as you can see, I am directly going to do A plus B. So basically I am going to add the elements of matrices A and B. I am not going to write down the matrix. Okay. So A matrix is 2 minus 3, 5 minus 4 minus 6, 1 plus 2, 1, 4 minus 1 and minus 3, 3. So when we are going to add the elements, the A plus B matrix is going to be 4 minus 2, 9 minus 9, 4 minus 5. Understood? Now we have to prove that A plus B transpose is equal to A transpose plus B transpose. Correct? This we have to prove. We have found out A plus B. Now let us find out what is A plus B transpose. Now in transpose, you know, rows are converted to columns. Okay. So rows are going to be converted to columns. So this matrix is going to change like this. 9 minus 5 minus 9, 4. Okay, so this is A plus B transpose, this is our left hand side. Now let us find out the right hand side. So before that, let us find out what is A transpose. A transpose is going to be, so the A matrix rows will be converted to columns. This is A transpose. This is going to be A transpose. Similarly, B transpose I am going to write over here. B transpose is nothing but 2, 4 minus 3. 2, 4 minus 3. Then 1 minus 1 and 3. Now I am going to add A transpose plus B transpose. So let us mark this as equation 1. And A transpose plus B transpose, so let us add 2 plus 2 is 4, 5 plus 4 is 9, minus 6 minus 3 is going to be minus 9. Similarly, minus 3 plus 1 is going to be minus 2, minus 4 minus 1 is minus 5 and 4 plus 3 is going to be, so 1 plus 3, that is going to be 4. So can you see that equations 1 and 2 are equal? Hence we have proved that A plus B transpose is equal to A transpose plus B transpose. Have you understood this sum? Please let me know in the chat box if you have. Also, I am going to send the exercise on the group so that all of you can solve the sums at home. Just give me a minute. I am going to send the exercise also so that you understand what is done. I am going to send the entire exercise. So that all of you can do this at home. Okay, I have already sent you exercise 2.4 for your reference. Now let us solve the next sum that is important. Okay, so Nidhi, you have understood? Already you have shared it with us. Yes. Now so I remember, Nidhi, that I had already told you that you have to finish exercise 2.4. Okay, but since you have said that we haven't done, so we are going to do it right now. Okay, then I'm going to move to the next part, that is inverse of a matrix. So now next question, as I had told you, was question number 8, may say the first one. No, the question number 8 only. Okay, now we are going to solve question 8 from your textbook. Let us solve question 8. From the same exercise 2.4, we have to solve question 8. Now, they have told us to find out or to verify that A plus 2B plus 2C ka transpose is going to be A transpose plus 2B transpose plus 3C transpose. So, Nidhi, you have to please remember the homework henceforth, okay? Today I have repeated this because we have been doing this after a long time, but I do remember what I had given you. So, you have to complete the homework regularly so that it will be easier for you to, as a practice. Doing practice of maths is very important, then only you will be able to solve it. Okay, so now let us directly do it. A matrix is given to us as 1, 0, 1, 3, 1, 2 plus 2 into 2, 1 minus 4, 3, 5 minus 2 plus 2c. So 2 multiplied by 0, 2, 3 minus 1 and 0. Okay. So now let us do this part. I hope it is visible to you. Okay, now what we are going to do is we are going to add. So first we are going to multiply B and C and then we will add all the three. So as you can see, I am going to multiply this. So it is going to be 4, 6, 10, 2, minus 8, minus 4. And this is going to be 2, 0, 4, 6, minus 2, 0. Okay. Now we are going to add all three. So the answer is going to be 1 plus 4 plus 0, that is 5. 0 plus 2 plus 4, that is 6. 1 minus 8, that is minus 7, plus 6 is minus 1. Then 3 plus 6 is 9. 9 minus 2 is 7. 1 plus 10 is 11. 11 minus 2 is 9. 2 minus 4 plus 0. So that is going to give us the answer as minus 2. Now, is anything wrong? Let me check. 1 plus 4 plus 0. 0 plus 2. This is going to be, oh, it is 3C. Okay, that's why the answer is not matching. Here it is 3C. So you have to multiply it by 3. Okay. So this is going to change, also this will change because we have to multiply it by 3. So 3 into 0 is 0, 3 into minus 1 is minus 3, 3 into minus 1 is minus 3, 0, 3 into 2 is 6, 3 3s are 9. Okay. So now these elements are also going to change. So tell me, what is the second element? 0 plus 2 plus 6, that is 8. 1 minus 8 is minus 7. Minus 7 plus 9. So it is going to be 2. Okay. 3 plus 6 is 9. 9 minus 3 is 6 over here. Then 1 plus 10 is 11. 11 minus 3, 8 again. And then we are going to get the answer as 2 minus 4. So it is going to be minus 2. Now we have to find out A plus 2B plus 3C ka transpose. Okay. So transpose, that means rows are converted to columns. So this is our equation 1, let us see. Okay. Now what do we have to verify? A transpose plus 2B transpose plus 3C transpose. Okay. So now Nidhi, can you do it? Do it and let me know what answer do you get. Okay, do it and tell me whether you get LHS is equal to RHS. I am not going to do this. Let me know if LHS is equal to RHS. So this is 5, 6, 8, 8, 2 and minus 2. Now we are going to do from question number 10, first one. After this, the question is, I am going to read the question from exercise 2.4, example number 10. Prove that A plus A transpose is a symmetric and A minus A transpose is a skew symmetric matrix. Okay. For the first, A is given to us. Let us solve question number 10 now. This you have to do it. There is nothing to be done. If LHS is equal to RHS, then you can directly say that it is verified. So we are going to solve question number 10. From that, the first one. Okay. So A matrix is given to us as 1, 2, 4. Next 3, 2, 1. And the last is going to be minus 2, minus 3 and 2. Now, first let us find out A transpose of this. So, we are going to convert rows to columns. Okay. So, 1, 2, 4, 3, 2, 1, minus 2, minus 3, plus 2. Okay, so this is our A transpose. Now what we are going to do? We have to first find out what is A plus A transpose. So I am going to do it directly. You know how to do the addition of the elements now. So 1 plus 1 is 2, 2 plus 3 is 5, 4 minus 2 is 2, 3 plus 2 is 5, 2 plus 2 is 4, 1 minus 3 is minus 2, minus 2 plus 4 is 2, minus 3 plus 1 is minus 2 and 2 plus 2 is 4. So now let us find out transpose of this particular matrix. See, when do we say that A plus A transpose is a symmetric matrix? We say it when A plus A transpose of transpose is equal to A plus A transpose. Okay, so now this is our RHS. Now we have to see whether our LHS is coming one and the same or no. So A plus A transpose of transpose, let us find out the LHS. And if it is equal to the RHS, we can say it is a symmetric matrix. So now this is our A plus A transpose, as you can see. What I am going to do? I am going to convert rows into columns. As you can see, LHS is equal to RHS. So this particular condition is satisfied. Therefore, we say that A plus A transpose is a symmetric matrix. Have you understood this part? Now, they have told us to find out to show that A minus A transpose is a skew symmetric matrix. Okay. So, when we talk about a skew symmetric matrix, what is the meaning of that? When do we say a matrix is a skew symmetric one? Okay, wait. If this is not visible, let me show you. I think now it is visible, right? Okay, now when do we say it is a skew symmetric matrix, Nidhi? A minus A transpose is a skew symmetric matrix when, see, I'm going to show you. We are going to say it's a skew symmetric matrix when A minus A transpose of transpose is going to be minus A transpose. Okay, so now this was our A. You know what was our A? This was our A and this is our A transpose. So we are going to first find out what is A minus A transpose. If this condition is satisfied, then we will say it's a skew symmetric matrix. Now let us find out what is A minus A transpose. I am directly going to do the subtraction part. I am going to tell you the answer as 0, 1, minus 6, 0, minus 1 plus 6, 104 and minus 6, minus 4 and 0. Okay. So this is our A minus A transpose. Now let us find out transpose of this. Okay. Now let us find out A minus A transpose ka transpose. That means again rows will be converted to columns. So it is 0, minus 1, 6, 1, 0, 4, minus 6, minus 4 and 0. Okay. So if you observe A minus A transpose, you see that each and every sign is opposite. So here it was A minus 1, here it is plus 1. Here it was plus 6, here it is minus 6. So is this particular condition proved? Yes, it is proved, and so we say it's a skew symmetric matrix. Understood? Shall we move on to the next part, Nidhi? Let me know in the chat box. Okay, alright. Next. Okay. Now next question which we were going to do is from question number 11. I think we'll do the second one. Basically it is similar, it is one and the same. So question number 11 is the same as question number 10 that we did right now. So let us move to question number 12, the second one. All the difficult questions will be solved by me, easy ones are going to solved by you. So basically you are going to solve all the easy ones. Now here we are going to solve question number 12, the second one. They have told us to prove that BA transpose is going to be A transpose into B transpose. Okay. So first they have given us matrix B as 0, 3, minus 4, 2, minus 1, 1, and A matrix is given to us as 2, minus 1, 3, minus 2, 4, 1. Okay. Now let us find out the multiplication. What is B into A? You know, while multiplication, what do we do? First row, first column. So first row, first column, we are going to multiply. Then next, first row, second column. Okay, then next second row first column. So 2 into 2 minus 1 into 3 plus 1 into 4, and then second row second column. So 2 into minus 1 minus 1 into minus 2 plus 1 into 1. So our answer is going to be, let us find out what is BA now. So this is 0, 9 minus 16. So this is going to be minus 7. 2 2s are 4. 4 minus 3 plus 4, that is 8 minus 3. So 8 minus 3 is nothing but 5. Here it is 0. 3 minus 2 is minus 6. Minus 6 minus 4 is minus 10. Okay. And the last is 2 into minus 1 minus 2 plus 2. So this becomes 0. So here we are going to get it as 1. Now let us find out what is BA transpose. So for BA transpose, again whatever BA is there, we are going to convert the rows into columns. Okay. Now we have to prove that BA transpose is nothing but A transpose into B transpose. Now let us find out what is A transpose. A matrix is given to us. From that we are going to find out A transpose, in which rows are going to get converted to columns. So here you can see the rows. Rows are getting converted to columns. And we also have B matrix. We are going to find out B transpose. That is going to be rows will get converted to columns. Wait, I am going to show you. Okay. Now let us multiply A transpose into B transpose. So take first row first column, then first row second column, plus it is 4 into 1, that is 4. Then second row first column, and second row second column. So minus 2 plus 2 plus 1. So 2 into 0 is 0, 3 3s are 9. 9 and minus 16 is minus 7. I think here also it is minus 7 itself, right? Yeah. See this one. Okay. Now let us check the next. 2 into 2 is 4. 4 plus 4 minus 3 is 5. Minus 1 into 0 is 0. Minus 6 minus 4 is minus 10. And plus 2 minus 2 gets cancelled. So 1 is the answer. So hence we have proved that BA transpose is A transpose multiplied by B transpose. Okay, so is this exercise done? We have finished with this exercise. Remaining sums you have to do as homework. Any doubts in this? Have I gone too fast, too slow, whatever it is, please let me know. Have you understood? I hope you have. We have already discussed the elementary transformations. Now, I want you to write down. Okay. All right, wait. Now from the textbook, as you can see, this we have already done. I was teaching you what is inverse of a matrix. Okay, and what is the uniqueness of inverse of a matrix? Just a minute. Okay, so now as you can see over here, we have already discussed what is the uniqueness of a matrix. Inverse of a matrix is denoted by a raised to minus 1. So we are going to learn how to find out the inverse, but before that, I want you to write down a few steps. Wait, I'll just show you. Okay, so now let us go to the solved example. I'm going to explain this solved example so that you understand what is an inverse. Okay, now see, what is the condition to state, that a matrix is an invertible matrix? Okay, invertible means what? First, you will find out the value of the matrix, as you can see over here. Okay, value of determinant A, which comes out to be minus 3, which is not equal to 0. So when the value of the determinant is not equal to 0, then we say that A inverse exists. If the value of the determinant is equal to 0, then we say it does not exist. Okay, so please remember this very well. Always for inverse to be there, you have to prove that the value of the determinant is not equal to 0. If it is not equal to 0, then an inverse exists. If it is equal to 0, then inverse does not exist. Understood? Any doubt, anyone? Good. Now see question number 2, in which they have told us you have to find out inverse of matrix A by elementary transformations. Okay, so first step is what? First step is going to be, you have to find out the value of the determinant, and value of the determinant is not equal to 0, which means that A inverse exists. Okay, so now here you can see what is A inverse? A inverse is nothing but opposite of A. Okay, so suppose let me give you an example of basic algebra. Suppose A is given to us as 4 by 3. So in this case, A inverse is going to be 3 by 4. So when we multiply A into A inverse, that is when we multiply 4 by 3 into 3 by 4, what answer do we get? 1. Okay, this is in the case of normal algebra. Is it visible? Okay, this is in the case of normal algebra. Now what I'm going to do is, I'm going to prove it using a matrix. Okay, so now here they have shown us A into A inverse is I. We already know. Okay, so A matrix is given to us. A and inverse, you have to write it as it is, because we have to find out the value of A inverse by doing elementary transformations. And as you can see here, the right hand side is nothing but an identity matrix 1 0 0 1. So now let us start doing the row transformations in such a way that you convert this entire matrix to identity matrix, so that we can get the A inverse. Okay, so first step what they have done, they have interchanged row 1 and 2. So here as you can see, row 1 and 2 is interchanged. Similar here also, left hand side and right hand side, the rows are interchanged. Now you want this as to be 0. Okay, so R2 is converted in such a way that it is R2 minus 2R1. So 2 minus of 1 into 2, so this becomes 0. Change both the sides. Next step what they have done, they have again changed R1 such that R1 is R1 plus 3R2. So after doing this step, as you can see, 1 0 0 minus 1 we have got. So now what we are going to do, divide R2 by minus 1. divide R2 by minus 1. So 0, 1, 1, 0 of A inverse is nothing but 3 minus 5 minus 1, 2. Have you understood this step? Now as you can see, this is nothing but I. Here there is a mistake, okay? This should be 1, 0, 0, 1 because that's an identity matrix. This is a mistake in the textbook. So I multiplied by A inverse, we have got some value. So that means, see, I is what? Unit 1. So whenever we multiply any matrix with I, answer is going to be the matrix itself, isn't it? So we have got A inverse, which comes out to be 3 minus 5 minus 1, 2. Have you understood how we have found out A inverse by using elementary transformations? Nidhi, please do let me know. No, ma'am. What is it that you have not understood? We'll solve one sum like this, then you will understand it better, I guess. Okay? Okay, so directly let us go to exercise 2.5. I'm going to solve the sum, then you will understand what is an inverse. Have you understood this concept which I have showed you over here? If A is 4 by 3, and so that A inverse is what? 3 by 4. When you multiply A into A inverse, you get I only, which is an identity matrix. Okay, and I multiplied by A inverse is going to be A inverse itself, because I is what? I is a identity matrix. So here in the case of matrices, I is nothing but 1. I is considered as 1. Understood this part? Now let us solve exercise from exercise 2.5. Let us solve the first one, the third one maybe. No. We will do, wait, I'll tell you which question we are going to solve from 2.5. Yes, question number 6, which you can see in exercise 2.5. We'll solve that first so that you understand how to find out inverse. Exercise 2.5 may say we are going to do question number 6. The first one is given to us. A is given to us as 1, 2, 2, minus 1. So now can we say A inverse exists? How can we say A inverse exists? We will find out the value of A. The value of A determinant comes out to be minus 5, which is not equal to 0. So we will say that A inverse exists. Have you understood up till here? All of you? This part have you understood? Now, by element, we already know that A into A inverse is nothing but I. Okay, this we already know. So now what I am going to do? I am going to write A as it is. A is given to us as 1, 2, 2, minus 1. A inverse is given to us, no, it's not given to us, we have to find out A inverse. And I is the identity matrix which is given to us as 1, 0, 0, 1. So now we have to perform transformations. So I am going to prefer row transformations. So if you decide that you are going to do row transformations, then from the starting itself do all the row transformations. Do not change to column transformations. Okay. Now what I am going to do is, see, I want this element to become 0, correct? Okay, so what I am going to do, I am going to change R2 in such a way it is R2 minus 2R1. So as you can see, first row remains as it is. 2 minus 2 is going to be 0. Minus 1 minus 4 is going to be minus 5. A inverse will remain as it is. On the right hand side also I am going to change or transform row 2 such that it is R2 minus 2R1. So I get minus 2 over here and I get 1 over here. Have you understood this step? This we are finding out A inverse by row transformations. Have you understood up till here? Now next step what I am going to do, I want 1 over here. correct, because in an identity matrix 1 is in this place. So what I am going to do, multiply R2 such that it is 1 upon minus 5 of R2. So now R1 will remain as it is and R2 will change to 1. So for R1 will remain as it is, R2 is going to change. So this is going to be 2 by 5 and this is going to be 1 by 5. On both sides you have to do the transformations. Okay. Now in this step, in this particular place, I want 0 to be there, so that this turns into an identity matrix, that is I. Okay. So what I am going to do, R1 I am going to change in such a way that it is R1 minus 2R2. So now 1 minus 0 is 0. So 1 minus 0 is 1 only. 2 minus 2 into 1 is 2 minus 2, that is 0. And R2 will remain as it is. On the right hand side also you are going to apply the same thing. As you can see on the right hand side I am going to apply the same thing. So here on the right hand side row 1 is going to change and row 2 will remain as it is. There will be no change in row 2, correct? So row 2 is going to be R1 minus 2R2. So R1 minus 4 by 5. So that is 1 by 5. Similarly here it will be R1 minus 2 by 5. So this is going to be minus 2 by 5. So as you can see, this is nothing but I into A inverse is equal to this 1 by 5, 2 by 5, minus 2 by 5 and 1 by 5. Okay. So I multiplied by A inverse is going to give me A inverse itself. So the value of A inverse is this. You have to write down the elements as they are. Have you understood this part? Are you writing along with me? Let me know. Okay. Okay. So this is a way of finding out inverse by transformation method. So in the exam, if they tell you that you have to find out inverse by by transformation method, that means you have to do row transformations or column transformations and you have to use this particular method to solve the sums. So from question number 6 we have done the first one. From question number 6 I want you to do the second one. Okay. Now similarly question number 7 we are going to do here. Right now we are going to do question number 7. Before that, let me send you exercise 2.5 also so that it becomes easier for you to solve it. Okay, till that time please write down. If you have not finished writing, please write down. The sums which I have sent you from exercise 2.5, those sums are to be completed as homework because they are similar type of sums, similar to what we have done right now. I have taught you only one method to find out inverse of a matrix, and that is nothing but transformations method. Okay. So now I am sending you exercise 2.5, the sums based on the method which I have taught you right now. So from question number 6 you will have to do the second sum, and we are going to do question number 7. Why? Because I am purposely taking question number 7 because they are nothing but column transformations which are done. Okay, column transformations are very essential, so that's why I am going to take question number 7. And then we are going to stop here for today. Okay, and we will be taking class next Tuesday now. See, most of you I can see are not present, some of you are there online, but please attend the sessions offline, then only it will be very easy for you to understand. Otherwise, maths is going to be difficult always. Okay. So now they have told us in question number 7 of that exercise to find out question number 7. A is given to us as 101, 023 and 121. Okay, now this is given to us. Okay, they have told you find out inverse of A if elementary column transformations by elementary column. So first step, find out what is A. So 1 into bracket 2 minus 6 minus 0 plus 1 into bracket 0 minus 2. This is minus 4 minus 4 minus 2, which is minus 6, which is not equal to 0. Therefore, A inverse exists. Now we are going to write it as A into A inverse. A into A inverse is nothing but I. Okay, have you understood? Now our A matrix was see, I can say A into A inverse is equal to I, or I can also write this down as A inverse into A. It is one and the same. I hope you understand. Okay, so A inverse into A. What is our A? 101, 023, 121 as I is nothing but 100, 010, now you have to do column transformations. Okay, remember, if they have mentioned that you have to do column transformations, then you have to do column transformations, otherwise you will not get marks. Means if a student, even though they have mentioned that you have to solve by column method, they do it by row transformation method and they are going to get the answer as correct, but still no marks will be given because they have mentioned the method to be used. Okay, so please read the question carefully, understand which method is expected and then do accordingly. Okay, so next part. Now as you can see over here, first I am going to change C1, first I am going to change C3 such that it is C3 minus C1. So there is no row involved now. Now we are going to do by the column method. So third column is going to change. So first column and second column will remain as it is. So third column, 1 minus 1 is 0, 3 minus 0 is 3, 3 minus 1 is 2. Sorry. Here also the same thing, first column and second column will remain as they are. Third column will change such that it is C3 minus C1. So this is minus 1, 0, 1. Okay, now next step, we are going to interchange C2 and C3. Double arrows, C2, C3 interchange. So A inverse C1 will remain as it is, 1, 0, 1. C3, C2 are getting interchanged. Here also the same thing. First column is going to remain as it is. Second and third column are getting interchanged. Okay. Now next step. We need 1 over here. We have to get 1 over here. So what I am going to do? C2 such that it is C2 minus C3. Write along with me so that you do not miss any step. Okay. So A inverse C2. So basically C1 will remain as it is. C3 will remain as it is. Here also C1 and C3 will remain as they are. Only now C2 is changing. So here C2 is C2 minus C3. So C2 minus C3 is 0. 3 minus 2 is 1. 2 minus 2 is 0. Similarly here minus 1 minus 0 is nothing but minus 1. 0 minus 1, 1. Now what we need to do is we need to get 0 over here. So what I am going to do? C3 column I am going to change in such a way that it is C3 minus C1. So now C2 will remain as it is. So A inverse C1 will remain as it is, C2 will remain as it is, and C3 is C3 minus C1. Here also C1 will remain as it is, C2 will remain as it is, and C3 will change. Okay. So 0 minus 1. Okay, what we can do is instead of doing here C1, we can change C2. Here C3 minus C2 will become easier. Yes. So C3 minus C2, here 0 will remain as it is. Then 2 minus 1 is 1. 2 minus 0 is 2. Similarly here C3 minus C2. So C3 minus C2 is plus 1. 1 plus 1 is 2. Okay. Now 1 0 0 0 1 we need a 0 over here. So again C3 I am going to change such that it becomes C3 minus C2. So A inverse, these will remain same. C3 is going to change, C3 minus C2, 0, 2, 0. So C3 minus C2 is going to become 1 minus of minus 1 plus 2, 3. Now what I am going to do? We need a 0 over here. In column 3, we require basically 0 0 1. So this I need as 0, this I need as 1. Okay. So now what can be done? Let us transform C1 Or one more step we can do. We will do C1, we will change such that it is C1 so A inverse. Now C2 and C3 are going to remain as they are. C1 will change. So C1 minus C3 is 1. This is 0. This is minus 1. That is equal to. So basically C2 and C3 will remain as they are. C1 will change. So C1 minus C3 is minus 1, minus 3, plus 2. Now, what I am going to do is, I am going to divide C3 by 2. So A inverse will be 1, 0, minus 1, 0, 1, 0. This will become 0, 0, 1. This will become 2 by 2, that is 1, 3 by 2 and minus 1. Okay. Now, the only thing which we need to transform is this. This has to be converted to a 0. So what I am going to do? C1 such that it is C1 plus C3. So C1 plus C3, C1 will change. Here C1 plus C3, 0 only. Here C1 plus C3, minus 1 plus 1 is 0. So now we have got an identity matrix here. Similarly, on the right hand side, C1 will change. C1 plus C3 is 0. And tell me what is minus 3 plus 3 by 2. So I am going to do it over here in the rough work. So minus 6 plus 3 is minus 3 by 2. And 2 and minus 1 becomes 1. So now basically we can say that A inverse into I is equal to this matrix. So A inverse is this matrix. Okay. In this way, as you can see, I have shown you all the column transformations. So from the start, when they have mentioned you have to do column, start with column. Okay. So I think we'll stop here for today. Do the sums which I have already sent on the group as homework, and next time we will study another method to find out A inverse. Okay. Bye bye everyone. We'll stop here.